In addition to the 0 over 0 indeterminate forms and the infinity over infinity indeterminate form, there are other indeterminate forms. 0 times infinity. All right, and notice if we have a product and one factor is going towards 0, getting small, and the other factor is getting big, that's sort of a tug of war. We don't know how that's going to come out. Infinity minus infinity, or negative infinity minus negative infinity. All right, and then we also have exponential indeterminate forms, something that's approaching 1 to the infinity, or infinity to the 0, or 0 to the 0. These are all indeterminate forms, but it's very, very important that L'Hopital's rule only applies to 0 over 0 or infinity over infinity indeterminate forms. To deal with any of these other indeterminate forms, we have to first convert them to either infinity over infinity or 0 over 0. Use it to apply L'Hopital's rule. There might be other ways we could deal with them, but if we're going to use L'Hopital's rule, then we'll have to convert them to either 0 over 0 or infinity over infinity. So let's take a look at this situation. We have the limit as x approaches pi over 2 from the left of x minus pi over 2 times the tangent of x. Now, as x approaches pi over 2 from the left, notice x minus pi over 2 is approaching 0, and as x approaches pi over 2 from the left, here's a graph of tangent. Tangent is approaching positive infinity. So this is a 0 times infinity indeterminate form. All right, we'd like to take this limit. All right, but before we can use L'Hopital's rule to take this limit, we have to convert it either to a 0 over 0 or infinity over infinity indeterminate form. Now, there's two ways to do that. We can divide, all right, by the reciprocal of x minus pi over 2, the first factor, or we can divide by the reciprocal of tangent of x. All right, here are those two options. We can divide by the reciprocal of x minus pi over 2, so x minus pi over 2 to the negative first. And so we'd have tangent, divided by x minus pi over 2 to the negative first, the limit of that as x approaches pi over 2 from the left. Or we could divide by the reciprocal of tangent to the negative first. And if we did that, we'd have an x minus pi over 2 divided by the reciprocal of tangent is cotangent. Now the question is there a right or a wrong? Well, no, there's not a right or a wrong. There's maybe, though, an easy or hard. I guess if we looked at this, all right, how would we like to apply L'Hopital's rule to this form, the first form, where we divided by the reciprocal of x minus pi over 2? And how would we like to apply L'Hopital's rule to the second form, where we divided by cotangent, the reciprocal of tangent? Well, if we look at the first form, I see that, well, the derivative of tangent, I'm going to have to do that to apply L'Hopital's rule. By the way, this is going to be approaching an infinity over infinity indeterminate form. The derivative of tangent, secant squared, it's not too hard. The derivative of x minus pi over 2 to the negative first is going to be negative x minus pi over 2 to the negative second. All right, and see, things seem to be getting worse there. All right. On the other hand, if I look at the other part, the derivative, if I apply L'Hopital's rule, by the way, this is going to 0 over 0. I haven't shown you a picture of cotangent, but it is. All right, if I take the derivative, if I apply L'Hopital's rule, I just get 1 in the numerator, and I get the derivative of cotangent, negative cosecant squared in the denominator. That doesn't seem too bad. That doesn't seem too bad to deal with. You might be a little bit uncomfortable dealing with cosecant, but remember, cosecant is just a reciprocal of sine. So if you think about that may be helpful. So I think I prefer to deal with this one. It's not that this is right and that's wrong. It's just that this is easier, I think, and this one's a little bit harder. So if I apply L'Hopital's rule, remember this is going to 0 over 0 now. All right, I'd get the limit as x approaches pi over 2 from the left of 1 over negative negative cosecant squared of x. And remember that that's the limit as x approaches pi over 2 from the left of 1 over negative 1 divided by sine squared of x, because cosecant is a reciprocal of sine. And inverting and multiplying, this would be the limit as x approaches pi over 2 from the left of negative sine squared of x. Now, as x approaches pi over 2, sine approaches 1, so this is going to be negative 1 squared, or just negative 1. Okay? All right, let's try another example. All right, the limit as x approaches 0 from the right of x squared times the natural log of x. As x approaches 0 from the right, okay, x squared approaches 0 times, as x approaches 0 from the right, the natural log of x approaches negative infinity. So this is a 0 times infinity indeterminate form. We have to ask ourselves, which would we rather divide by? The reciprocal of x squared, x to the negative second, or would we rather divide by the reciprocal of natural log of x, the quantity natural log to the negative first? Well, if I'm going to apply L'Hopital's rule, I don't think I want to be dealing with that quantity natural log raised to the negative first. I think I'd rather be dealing with the x squared to the negative second in the denominator. So let's take this limit as x approaches 0 from the right of x squared times the natural log of x. And as I said, I'm going to divide by the reciprocal of natural log of x squared, I should say. So I'll have the natural log of x divided by 1 over x squared, or that will be the limit as x approaches 0 from the right of the natural log of x divided by x to the negative second. We can see here that this is going to be an infinity. Remember, natural log of x goes to negative infinity over infinity. As x goes to 0, the 1 over x squared goes to infinity. So we can apply L'Hopital's rule. In this form, it's pretty easy. This will be the limit as x approaches 0 from the right of 1 over x divided by a negative 2 over x to the third. Maybe I should just write it as negative 2 times x to the negative 3. Okay, but that is the limit as x approaches 0 from the right of 1 over x divided by negative 2 over x cubed. Now this is still approaching an infinity over infinity indeterminate form, but I think you see if we keep on taking derivatives, well, things are going to start to get worse here. So let's, instead of doing that, let's resort back to algebra. A part of the art of using L'Hopital's rule is know when to stop using it. And in this case, I think things will simplify pretty easy if I just multiply by the reciprocal of negative 2 over x cubed. I'll have then the limit as x approaches 0 from the right of 1 over x times x cubed over negative 2. And notice one of the x's cancel. And I'm left here now with the limit as x approaches 0 from the right of x, I think there would be an x squared left here, of x squared over negative 2, and that's simply going to be 0. So this limit would have turned out to be 0. Okay. All right. In the next video, we'll discuss the next indeterminate form, infinity minus infinity.